Okay. Yeah, hi. Today I am discussing now continuing the concept related to thread. Okay, now I am discussing what are the benefits with multi-thread and what are the drawback with the multi-thread, and we'll go deep on to the thread object contain start method, abort method, join method, is alive property. Like that we can go into the depth of this method, and finally if any exception happen, how the exceptions need to be handled, and then what are the best practices when we are using threading. So I will start with what are the benefits with multi-threading. Okay, suppose not actually uh, suppose if your application is designed based on the multi-thread application. This is my app. Internally it uses multiple thread multiple thread. Each thread responsibility is for functioning some task. Suppose your application is a multi-thread application. Now your engine is a single process engine. Then what happened? Then what happened? I will draw the time diagram. This is the time and these are the task. Assume it is a single task only instead of combined, we will say. This is the task. Okay, if so to complete this task in a single machine which is in single thread, this much amount of time is consumed. But whereas suppose the same task, and if we design if our application is to be run in multi-core or multi-thread, then what happen is a single core machine. Note here, you note down single core machine. This application is designed with single thread. Now this application is designed with multi-thread, which is now single thread application, multi-thread application dumped in single core machine. The tasks are same. How it is doing? As you know, you have to remember here is single core. So this is the it is doing n by 4 task. N by 4 task. One second. It is doing n by 4 tasks, and this much amount of time it is doing nothing. It is sitting idle. Now again it is doing the same n by 4 task, and then after this much amount of time it is sitting idle. Then it is doing n by 4 task, then it is sitting idle. Now again it is doing n by 4 task. So the same application which is designed based on the multi-thread, if we deploy it in single core machine, it take time more than the single core machine, means it take time more than the single thread application. Now we take the same application. Now suppose this is application 1. The responsibility of application 1 is same, but it is designed with the single thread. Now the same application, same responsibility, it is designed with multi-thread, means so we seen the drawback of the multi-thread application deployed in single core. Now the same multi-thread application deploy in multiple core, then this is n by 4th task, this is n by 4 task, this is n by 4 task. So first task is, so total time is more approximately t1, because we have 4 core machine, each core doing the 1 by 4 task. Okay, so our application designed with multi-thread, if it is dumped in multi-core, then only we get the benefit of the multi-thread application. Otherwise we have to design our application with single thread only. Now it is almost all applications, all core or multi-core engines only. Now coming to the next, what are the benefits we see with multi-thread is, suppose we have requirement is a CPU bound operation like image processing. For that image processing, it is purely dependent on CPU utilization. So our application is designed with multi-thread, means parallelly our application is designed parallelly process, then also it doesn't affect in the end result, then this application will get the benefit by using the multi-core. Because so application task is there, task 1 image processing. If we have written the algorithm in such a manner that if it is run in parallelly, it will not affect in the end result. So if we design our application like that, and this, because in this scenario, if it will be benefit of multi-core, first core take the one task, second core will take the one task, third core like that. So wherever CPU bound operation, CPU demand is required, at that place we are using the multi-core by minimizing the time. Suppose I have requirement that generation of the serial number, unique identifier number, like in production 1 lakh, 2 lakh, 10 lakh, 50 lakh, like that is requirement is there. Then I use the if I use design our application by using the multi-thread, then it take minimum time. Okay, in those scenarios also we have the benefit by use of the multi-thread application. Next, I found in the scenarios where we have in our application multiple tasks are there. Some tasks, all tasks mostly divided into CPU task, IO task. So whenever our application doing IO task, at that time, instead of blocking the thread, we can use for CPU bound task. So CPU bound task perform CPU bound tasks whenever waiting for IO bound work. Okay, this is the third benefit. Lot of benefits are there, but from my point of view. And finally I can say that mostly actually the multi-thread application is designed mostly to improve the responsiveness. Because if only one thread is there, if one application is there, then system is stuck. That's why what happened is, another thread concept is arises and abstract the concept of CPU into the thread, and the concept of multi-threading is arises mostly to improve the responsiveness. After that, our main concentration design multi-thread is to improve the responsiveness. Then after, it will help in benefiting in CPU bound operation, like that. Okay, these are the benefits whatever I described. Now coming to the problems we found when using with the multi-thread are multi-thread problems. Okay, actually from this figure only I will explain the scenarios. Mostly there is only one problem, context switch problem. Context switch is nothing but okay, context is nothing but we have a scheduler. This scheduler is a thread scheduler. Suppose I say this thread scheduler, actually if suppose our application is single core application, means single process are there, thread scheduler responsibility is to dump the thread which need to in ready state. Ready state means after ready state it need to CPU will pick up this thread data, state data, registered data, and CPU is executing. Now our requirement is to improve the responsiveness, that's why we are using multiple thread. So there is a single CPU there, multiple thread are there. So these threads are in waiting queue, and only one thread. This is in running queue, means the CPU is running this thread. After certain duration, to give the responsiveness to the end user, which is using different process, multiple process simultaneously. So the thread which belonging to that process, this is the thread of SQL process. This is the thread of Notepad. This is the thread of MP4 application. So thread scheduler will take this thread and dump into the CPU, and then thread scheduler will take this thread and make as a running and finally dump into CPU. So the lot of task which is done by the thread scheduler, that task is unnecessary for the end user point of view. What it is doing, it is taking the state from the CPU register and store in the thread object and make the thread object in, instead of running to some ready or waiting. We'll explain those concepts laterly through about how we are doing the thread from running to ready state. Now thread scheduler is doing unnecessary task. Unnecessary means changing the thread object from the CPU to the where thread scheduler to the thread queue, making that thread as in waiting to running queue, likewise running to ready queue, like that thread scheduler is doing those tasks. So we are saying that those tasks which is done by the thread scheduler is nothing but, from end user point of view, those are the unnecessary tasks. But internally, to make our application responsive, we have to do these tasks. Those changing happening, it is nothing but the context switch. This the context switch problem is there with multi-threading. Okay, next problem is synchronization problem. This is the main. Suppose there is a requirement, two processes are there, process 1, process 2. Those are run parallelly with multi-threading, and there is a requirement that it is need to extract the shared data. It is need to extract the shared data. This is the place where problem we arises with multi-threading. So if there is a requirement of shared data, one thread must to be hold. Okay, this is the problem we seen with multi-threading. Okay, I will explain later related to those topics like a thread object and what are the different types of thread, background thread and foreground thread, and how the what is the lifetiming of the thread, and how the exception it is handling. If exception is not handling, what the CLR take the responsibility, and suppose if asynchronous exception is happening, how we are handling, and how CLR is handling, and how two threads are there, and I need to make one thread as a I need to communicate to one thread. You need to stop, how the communication will be maintained. These topics will cover in next video. Okay, thanks, bye.